Hi guys, if you've ever wondered how we got to the moon, and I know there's those of you among us who don't think we got to the moon at all, but I'm talking about the first missions, although the recent mission is very kind of similar in many ways. We used, how we didn't get lost is we used a device called a Kalman Filter, and I've got one built into this embedded system here. This is an Atmega 2560. That's written in C code. It's not an Arduino, although the board is a Arduino Mega 2560. This here, this tiny chip here, well actually it's on the board, I don't know if you can see it, is the MPU 6050. And I've shown you that before with my control system. And it's got a built-in accelerometer and a gyro. And what we do in the coding here is we combine the two. The reason being that one of them is better at low frequencies. I think that's the accelerometer. And the gyro is better at high frequencies. So if we integrate the gyro twice, we get position. The accelerometer twice, we get position. If we integrate the gyro one time, we get position, but it's very noisy, so we combine them using a Kalman filter. You'll notice as I move this that the thing moves with it, it follows, it tracks it. So that's the pitch that way, and this is the roll. Okay, so if you're going to the moon, you need to be able to go from A to B with as small an error as possible, and that's where the Kalman filter comes on. Now nowadays, when I read about it, they use extended Kalman filters, which is a extension of the Kalman filters. Again, been around since the 1960s. This was in Kalman filter, which this is using, was around since 1961. Invented by a guy called Rudolf Kalman. The extended Kalman filter wasn't by him, it was an extension of his work though, and that was also around in the 1960s as far as I can remember. It was definitely in the 70s anyway. The modern Artemis mission uses three extended Kalman filters, I think. I can't remember now, but at least three. Whereas the original Apollo missions, they used one Kalman filter, and that was based into their small computer, which was written in something like assembly language, very low-level language to fit it in. It's really clever stuff. You'll see this also, apart from in your mobile phone, when you tilt your phone, the same chip is used. You'll see these also in other devices like a quadcopter, to keep the quadcopter stable. So you've got something like a quadcopter and it tries to tilt, for example, and you need it level. This sensor will detect when it tilts, and the control system, which will control the propellers at the top, will stabilize it flat again. So there we have it, the Kalman filter implemented on an Atmega 2560. For those of you interested, it's a Riccati equation that it's solving at each sampling interval. It's not sampling very fast, but it doesn't need to for this particular application.